Hi everyone, so in this video I'm going to teach you how to do integration by partial fraction decomposition. So the first example I have is the integral of x minus 9 over x plus 5, x minus 2 with respect to x. Okay, so looking at this problem, you don't really have a specific way to integrate right off the bat. And so when you have a fraction that looks like this, where you have a numerator over a denominator that can be factored, you want to use partial fraction decomposition. So what you would do is, to the fraction itself, you want to set it equal to some number, so a, over the first factor of the denominator, plus some number b over the second factor of the denominator. So yeah, when you do this, you want to make sure that the denominator is factored and that the fraction itself is proper, meaning that the power of the numerator is less than the power of the denominator. So now that you have this, you can multiply this entire thing by the denominator. So it would be multiplied by x plus 5, x minus 2. What this does is, in the left side, you can cancel out this entire thing, right? So you can get x minus 9 equal to, and then on the right side, for the first fraction, you can cancel out x plus 5, and you're left with a times x minus 2. Plus, in the second fraction, you can cancel out x minus 2. You're left with b times x plus 5. So from here, what you can do to solve for a and b, you can plug in just numbers that make one of them 0. So for example, if we let x equals 2, then a times 2 minus 2 is just 0, right? So you're left with 0 plus b times 2 plus 5. And then on the left, you're left with 2 minus 9. So that equals negative 7 equal to 7b. So b is equal to negative 1. So there you found your first constant. We can do the same thing, but you substitute a number that makes b equal to 0. So let x equals negative 5. So on the left, we get negative 14 equal to negative 7a plus 0. And so a is equal to 2. So now you have both of your constants. The magic here is that now that you have a and b, you can basically rewrite your integral with the partial fractions. So a is 2, so 2 over x plus 5. By the way, I'm referring to this right here. Okay, so 2 over x plus 5 plus negative 1, which is b, over x minus 2 dx. And now this is something that we can integrate by using logarithm rules. So this equals to 2 ln x plus 5 minus ln x minus 2 plus c. That is your answer. Okay, the second one I'm going to show you is something that requires 3 fractions. So this one says the integral of x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x dx. Before we start, you want to make sure, is this proper? Yes, it is proper because the power of the numerator is less than the power of the denominator. Then we can proceed. So here I'm going to rewrite this by factoring out the denominator. So when you factor out the denominator, you get x times 2x minus 1 times x plus 2 to the power with respect to x. So what we can do from here is x squared plus 2x minus 1 over all of this. We can set that equal to some constant a over the first factor plus b over 2x minus 1, which is the second factor, plus c over x plus 2, which is the third factor. So here we have 3 fractions that we broke this down into, and similar to the last example, we're going to just multiply everything by the denominator. So in the left, we can cancel this entire thing out. We get x squared plus 2x minus 1. And then on the right side, for the first fraction, we can cancel an x. And we get a times 2x minus 1 times x plus 2. Okay, and then for b, we can cancel out 2x minus 1. We're left with plus b times x plus 2. And then for c, we can cancel out x plus 2. We get c times x times 2x minus 1. Okay, and then from here, we can just substitute in variables, or actually constants that make some of them zeros. So let x equal to -2. I noticed that -2 will make that 0. So we get 0 for a plus, same thing with b, 0 for b, plus, and then for c, we can actually substitute in -2 and get a number. So that would be 10c. And that is equal to -1. So when we solve for c, we get -1 over 10. And then same thing with everything else. To solve for a, we're gonna substitute in a number that makes both b and c 0. So find the constant that they share, and it's x. So to make x 0, we just let x equal 0. And so on a, we get -2a equal to -1. And then so a is equal to 1 over 2. And then we're going to let, same thing to solve for b, we're going to find what factor that a and c share, and then substitute any number that makes that factor 0. So for a and c, they share 2x minus 1. To make 2x minus 1 equals 0, you substitute in 1/2. So let x equal 1/2. And if we let x equal 1/2, on the left, we get 1 over 4. On the right, we get 5 over 4b. And I'm just skimming through these calculations because they're pretty easy to do. So for b, we get 1 over 5. So now that we have our c value, we have our a value, we have our b value, we can basically rewrite our integral in this partial fraction. So for a, we have 1/2 times 1 over x plus b, so 1 over 5, times 1 over 2x minus 1, plus c, so -1 over 10, times 1 over x plus 2, all respect to x. So this is something that we can solve easily. So when we integrate this using logarithm rules, we get 1/2 ln absolute value of x plus 1/5 ln 2x minus 1, and then using chain rule, we divide by 2. And then minus 1 over 10 times ln x plus 2. Okay, and then plus c. And then when we simplify further, we get x ln absolute value of x over 2 plus ln absolute value of 2x minus 1 over 10 minus ln x plus 2 over 10 plus c. And that is our answer. So yeah, that was how to do partial fraction decomposition. I hope that was helpful, and I'll see you in my next video.